Welcome again to my channel. Let us see with Josh. So today we want to see how to write function in C. See, most of the students will have a problem in writing functions. So how to think for writing a functions for some problem solving. I am not dealing today with what function is, what are advantages of that, but how we can think to write a program using functions. You might have seen already what are different ways that you can write functions. It depends on a return type and number of arguments or parameters you are passing. So there are four types that we can write function, that is without a return type and without parameters. Second way is without return type with parameters. With return type without parameters. And the last one is with return type and with parameters. See, for writing these four different ways, you have to change just thinking. Thinking in the sense you have to think accordingly. Now, what is required, that I'll give you an idea. Always whenever you are writing functions, see function, what is function? It is subprogram and it is doing some task. So somebody calls that function does some task, and that will be used by the caller. So always there will be master and slave relationship. Master and slave. Assume master is always caller, instance caller, and this is function called. Slave means function called. So then how master can give orders to slave, whether it needs to send something, whether it needs the slave, whatever function, returns something. Depending on this, these are four types. I'll explain. The first type, without return type, without parameters. This what? Without return type, without parameters. I'll take example of addition of two numbers. I want to add two numbers. Now how this way you can write what will happen in this master slave. Now without return type, the function I want to write without return type and without parameters means what? Master is calling this add. Master is not sending anything, or master is not expecting anything. No return type and no parameters it is sending. This first type, whatever we are seeing, whenever call is given in master or a caller, function caller, then it is not sending anything and it is not expecting anything. Always see, whenever you see these four types, look for these three processes that required: read, process and give output. Who is giving output? These three tasks have to be done for any program. Now, whenever master is saying to slave, add two numbers. See, he's not, this means he is not saying or he is not sending anything and he is not expecting anything. He just says, add two numbers. Now, what is slave should do? Whenever he is saying add two numbers, the slave should read two numbers. Read two numbers. Slave should process that two numbers. And slave should give output of that addition of two numbers. So what master is doing, just it is calling that function. And everything, reading, processing, giving output, that will be done by slave. So this is just like I am a master, somebody is slave, I'll say add. Now I am not sending two numbers to him. I am not expecting addition. So he will read, he will add, and he will return me, he will give output also. So this is the first without return type, without parameters. I'll give you example of this later for all whatever types. Just we'll see what exactly we are doing. So this add function will all this. Now second type we will see. Second type. What exactly it means without return type but with parameters. Now what task, how call will be and what task it has to do. In this second type, without return type with parameters, the call will be like this. I am the master. I am calling slave for addition of two numbers. But my statement now, order now changes for this second type. I am sending parameters now, what to add. Now what I am saying, add 10, 20. I am just saying add 10, 20 to him. Now 10, 20, whatever I am giving, I am main, I am master. I am giving 10, 20. So who is reading these numbers 10 and 20? I am reading. That is master is reading. Means master is sending this 10 and 20, means reading business. The reading of two numbers will be done by this master now. Read two numbers will be done by master because he is sending. But he is not expecting anything. He is not expecting anything from slave. Now what is task of slave? Whatever 10, 20 given to slave, it will add that, means processing. In process it will do 10 plus 20. Now master is not expecting anything from slave, means giving output also will be task of this slave, right? So master will call by sending two values. Suppose instead of this I will say x and y. So xy, who is reading xy in this master? Or just for clarity's sake, master is main function. In main we have to read these two values and call this function. Then this will be taken by slave, copied in, then it will process, it will give output. So reading is done by this, processing and giving output is done by this. This is second type, without return type and without parameters. Then the third type, with return type without parameters. Now what way, who is doing what task? With return type, expecting something from function or slave. Without parameters, not sending anything. This is how the master gives order C. Add two numbers. Give me the result of addition. Add two numbers. Master is not sending two numbers here. What master is doing? Master is saying just add two numbers, but give me the result. Means whatever, see, it is not giving anything. It's not giving anything, no parameters. But caller is just calling and getting some value from add function. Now, who is doing what? Who is doing reading then? As master is not sending anything, reading is the business of slave, reading of two numbers. Processing is business of slave, that is addition of two numbers will be done by slave. Now after doing this, slave will return some value and this output is business of this master. Output means nothing but this value. If you want to use somewhere, you can use. Either you can print or use that somewhere. So this will be the scenario in third case without return type. Sorry, with return type. You are expecting something from function but without parameters. You are not sending any parameters. So this is third. Then fourth way with return type with parameters. Now who will do what? Let us see. Now how this with return type, I am expecting something from slave or function. With parameters, I am sending also. So how I am giving order C? Add 10 and 20. I am sending two parameters now. Add 10 and 20. Give me the result of addition. I am saying add 10 and 20. Give me the result of addition. So what? Who is doing reading? As I am sending, I am main, I am master. I am sending two values to him, function. So who is reading? I am reading. Master is reading. So whatever read values, that will be sent. That will be sent to a function. So reading business will be done by master. Then x, y, whatever two numbers I am sending, this slave or function will process that. Process means it will add two numbers and it will return it will return the value. That returned value will be in sum. Now who will give output or use that number? This master only. So who is doing what? Depending on that, you have to think in this way only, master-slave relationship, and who should do what. If there is a clarity, then you can write any functions. So we will see what these four ways how to write this add function only. I'll write program for this four types, how to think and how to write. We will see first without return type, without parameters for this addition. What I am saying here, just slave I am calling add two numbers. So master I will write master. This master. What master is doing? Is he sending anything? No. Is he expecting anything? No. So just there will be a call for that function. Who is doing reading? Who is doing processing? Who is giving output? Slave itself, function itself. So when I am writing this first type without return type, we show that by void data type. Then function name, and I am not sending anything to it. Now what add should do? Add should read two numbers. So printf enter two numbers. Then two numbers will be read, %d, and in suppose x and in y you are reading these two numbers. You have to declare x and y. Then sum is given, processing. Two numbers you have, this function has, x plus y will be done. and it will print output also. Printf. Sum has not been declared. Sum will be declared locally. Sum is given. Addition is %d, and at this place we are writing sum. That's it. How the execution takes place, see. Always execution starts from main. It will come, control comes here. There is a call to add function. Control goes to this function. Then it will declare this x, y and some variables. Enter two numbers will appear. Two numbers, whatever you are entering, that will be stored in x and y. That x, y will be added. Calculated sum will be given to sum, and this is sum. This is reading input, this is processing, this is giving output. These three steps will be done by this. Now if I want to write the second type, what is that? Without return type but with parameters now. Without return type with parameters. Now what changes will be there here, we will see. Now see, without return type, I am not expecting anything from function, but I am sending two values. So who is reading? As I am master, the caller is sending two values. This master should read. So I'll say printf enter two numbers, then scanf, same reading whatever statement you have written, that you can write here. Now this x, y, you have to declare x and y. Then call to a function. You are sending values, so call to a function like this, add x comma y by sending these parameters as parameters. Now the reading business is done by master. Reading business. Now what add will do? Add will just process. So integer sum will take here two parameters you are taking. Suppose for clarity sake I'll take a integer b, then sum is given a plus b. Processing is done. Then it will say printf addition is %d, and that's sum. That's it. This will. So what is this? Whenever without return type, master is not expecting anything, but it is sending two values, means read will be done by master, processing and giving output will be done by slave here. Now as you see this in functions, you might have seen these are formal parameters. Formal parameters. What is formal parameter? Parameters declared in function definition. Function definition, that are called formal parameter. And parameters in function call are called as actual parameters. See, today we are saying only how to think of writing functions, so I am not covering all these things. Now, see, you can write in many ways. Without sum also directly you can write here. Other way, if I want to write this way also, a plus b, that's it. It will do whatever. What will happen? This x, if suppose 10 and 20 you are reading, how the control goes, see. 10 and 20 you have given. 10 will be copied into A, 20 will be copied into B. Now A plus B, A value has 10, B value has 20. 30 will be printed at this place. So this is execution of this particular program. Now we will see with RT without parameters. With RT, return type. Main master is expecting something from others. Slave. So when master is expecting, printing output will be business of this main. What this function, I am not sending anything. How there will be a call? What we are doing? Without parameters, not sending anything. Add two numbers. I am not sending exact two numbers. I am saying add two numbers. Give me the result. Add two numbers. So who is reading? Add two numbers. I am not sending, no. Means master is not sending. So business of reading is of add function. So I am not sending any parameters here. The signature will be like this. But it is expecting a return type. Return type. This will be the signature. Now, not sending anything. This reading business is not of this. So what it has to do, it has to call this function without sending any parameters, and it has to, whatever this function returns, that it has to collect. Suppose sum. So this sum you have to declare in main. Whatever variables you are using in the function, that this should be declared. So add will be called. What is task of this? It should read two numbers. So printf enter two numbers is, then scanf that two numbers, whatever it is giving, x and y. So this x and y should be local to this. So you have to declare x and y. Now x and y you are reading. What it should do? It should process also. So sum is given x plus y. Sum declared here as you are using. Now it is not printing output. It should return the value. So what value after addition, whatever integer it gives, that value you are returning. So return sum. That's it. So how who will print now output? This main function will print output. Addition is. Where is addition now? Add whatever sum returned by this function will be taken in sum, and that you are printing here. That's it. How the control or execution starts from main. Sum is declared. Add is called. Here two values will be read, x and y. Suppose 10 and 20. 10, 20 will be added. 30. 30 will be returned. 30 will be returned to this sum. And then this sum is different, this sum is different. Keep in mind, this sum is different, this sum is different. This sum's scope and visibility is this function only. This sum's scope and visibility is this function only. So it will give to this sum, main sum, and the sum will be printed. This is third type. Then we'll see with return type and with parameters. Always this will be used mostly. Now what is this? What I am saying, I am sending parameters and I am expecting the result also. So what way I can do this? I am saying add 10, 20 and give me the result. So who is doing reading? I am sending, so I have to read that two numbers. I have to read two numbers, means master has to read two numbers. I am reading two numbers. Suppose this is printf enter two numbers, scanf that two numbers in x and in y. So x and y will be declared here. Now what I am sending this. So when sending two numbers, two formal parameters required, suppose integer a, integer b, what will happen in this case? Call will be made. This x, y you are sending, it will add. Then master is expecting return value also of addition, sum. So sum is to be declared here. Then whatever addition it gives, the sum is available. So it will print the addition is %d. Now at this place I am printing sum. What read is main is doing here? It is reading, it is printing output. But who is adding actually? Addition of the two numbers will be done, only processing is done by add. So what it will add, sum is given, this a plus b, whatever you are sending, actual parameters will get copied into formal parameters. So 10, 20 if you are reading, 10, 20, 10, 20 will be in a and b, 10, 20 will be added, 30 you are getting, and you can write return sum. As this sum you are using here, you have to declare that sum. Now see, always keep in mind, whatever formal parameters you have, that will act as local variables to this function. You are accessing here a and b. There is no need of declaration of a, b here, because already formal parameters acts as local variable to this. So how many local variables add can use? A, b and sum now. So a plus b you are doing, you can access, that will be given sum, and sum you are returning, that returned value will be here. In short, without taking this also, directly you can write return this a plus b also. That's it. Whatever, how the execution takes place, execution starts from main, xy sum will be declared, enter two numbers you are saying, two numbers you are reading, that two numbers you are sending in a and b, that will be copy, that is call by value, and a plus b will be done, that value will be returned, the returned value will be taken into sum declared in main, then addition is sum, that will be printed. So these are four types, and this way just you have to think who will read, who will write or process, and who will give output. So if there is a clarity, then you can write any functions easily. Always whenever you write functions, keep in mind that it should be cohesive. Cohesive function. Cohesive function means function should be cohesive. Cohesive function means it should do whatever the task is given. It should not do other tasks. Whenever I am saying add two numbers, that function should add only. It should not read, it should not print output. It should only process, that addition of two numbers should be done. Whatever with return type with parameters we are saying. In addition, in the last case, only it was doing addition. So always function should do only the intended, whatever name you are giving, that task should be done. It should not do any other things. That you should take care of, so that reuse will be more. We'll see what that reuse. If suppose cohesive function we want to write for sorting. Sorting requires list of numbers. Reading should not be done by sort function. Giving or printing that list, sorted list, should not be business of sort function. What it should do, list is taken by sort, then it should only sort. But printing and all, reading of list and printing of list should be done by master. Sort should do only sort. Then it will form a cohesive function. So this you should take care of. Assume we'll take one example of how to write, how to think. I want to write a program for calculating factorial of a given number. Factorial of a given number. So what way I can do? See, first of all, keep in mind, whenever before writing anything, think you are a master. Now, I want to use services of other slave. I don't want to calculate factorial. I want to give that to somebody else. So what way I want to give this task? Factorial, as I said, cohesive function. Factorial should calculate only factorial. Right? It should not read the number, it should not give output. Means what way I can call that? Say, I am saying calculate factorial of 3 and give me the result. Means I am sending, I am receiving the result, right? Only processing will be done by the function. So first of all, just keep in mind who is doing what. You should clarify yourself. Factorial calculation. Fact, I'll give function name. So what how I want to call that? Calculate factorial of 3. I am sending one value. So there should be one receiver, one formal parameter should be there. Suppose n. Then I am saying give me the factorial value. So this factorial will return some integer value. So this will be signature of factorial, whatever I want to do. Now who is doing read business, who is doing write processing, who is doing output? See, main. I am sending to one value here, factorial. Which number you want to calculate? I am saying calculate factorial of 3. Means 3 I am sending, master is sending. So that number should be read by master. So I will say printf enter number for which you want to calculate the factorial. So that number I am storing in some num. So num has to be declared here, integer number. So I have reading business is mine. Now I am calling, I don't want to calculate. I'll send that number to function. So send means I have to call this factorial and I'll give number as parameter. I am sending value. In turn, it is giving me, return me some value that I'll say in result. So result I am using here, so result I have to say. Then this is called, it will process. So processing business is done by this, because whenever I am saying calculate factorial of 3, give me result. Reading and printing output business is of master, but what slave is doing? Only calculation of factorial. Now you know factorial logic. Always whenever you are multiplying something, some series of numbers, we have already seen how to do that. Take one variable, suppose this product you are calculating, product of some numbers, always initialize this by 1 whenever you are multiplying something. This factorial calculation is nothing but, if suppose you want to calculate factorial of 3, you are doing 1 into 2 into 3, right? So whenever there will be series of multiplications, first take one variable and initialize that 1. So first of all 1 into 1 will be done. Then the result into 2 will be done. See, 1 into 1, 1. That result into 2, then 2, then result into 3. That way it will go on. So for this I, what the 1, 2, 3 up to n values you have to multiply. So I1, I less than or equal to whatever n you are calculating, I plus plus. This logic and all, I'll keep videos on this later phase, where how to think for a logic. So what we are doing, product is given, product into this I value. If I do, it will calculate product. Now in product, when it comes out of this loop, it will have product or factorial in prod, and that prod you are returning. So this way, product will be returned, that will be taken into sum result, and then I'll printf factorial is %d, and at this place this result whatever I have that will be printed. So execution takes place here. Number and result declared, enter number. In number, suppose you have read 3 value, fact of 3 is called, 3 will be copied into n. Product is initialized to 1. How it will do, see. Product is initialized to 1. N is here 3. Then it will come here. I value. Initially I value will be 1. 1 less than n. What is n value? 3. Less than or equal to n, true. When true, it will come inside. What is current product? 1. What is I value? 1. 1 into 1 will be given to product. So product will be 1. Again it will go to I plus plus. I value will be 2. It will check condition. 2 less than or equal to 3. Yes. Will come inside. What is current product? 1. What is current I value? I value is 2. 2 into 1 will be done. 2 will be assigned to product. 2. Then I will be incremented. I will be 3. 3 less than or equal to 3. Yes. It will come inside. What is current product? 2. What is I value? 3. 3 into 2, 6 will be assigned to this product. Then I value is incremented. I value will be 4. Now whether 4 is less than or equal to 3? No. This will be false. When false, it will come out of loop. Then what is in product currently? 6. 6 will be returned here, and that 6 will be printed. So this way the thinking of this is done. Then without returning, can I write this? So this call by reference can be used here. Call by reference concept. See what way I want to write. Same function, I want to write this way, but this function should write the output in my area. Okay, what exactly I want to say here? See, I don't want to get it returned. Now instead, what I'll do is I'll pass number and pass address of result variable. Address of result variable. Now containers, formal parameters should be of same type. This num is of type integer. This result is address. This parameter is address of integer. Address of integer. Address of integer, container should be pointer variable, because what is pointer variable? It stores address. Now which address we want to store? Integer's address. So what should be the parameter now? Int star. Suppose I am taking p here. These two parameters I am sending. Now see what changes I have to make so that it will write this product whatever into this result, my area. So what will happen? Number is passed to n. This address is passed in p. So here in this case, Now here, instead of returning product, what I can do is I can write here star P is given this product. That's it. Or you can manipulate this result here. I'll show what is exactly happening here. Let us see. This is mains area. Somewhere number is in memory. This is mains number. You are reading as 3, suppose here. Now result is one variable. Result is one variable. Its address is suppose 1000. Now we are calling this n. Somewhere n will be there in memory. This number will be copied into this n. So 3 will be here. Here there will be some garbage value. Let us see. Then P is one pointer variable. Pointer variable. What it can store? It can store some address. So what you are passing from here? Address of result. What is address of result? Suppose 1000. 1000 will get copied into P. So 1000 will be here. Means what? As if this is pointing to this area result. Now result is declared in main. Now this P is pointer to mains area now. So in this case, what is happening? This is copied, n is copied, 3 will be copied here, 1000 will be copied here, product is initialized to 1, this will be calculated. Now see here, 6 will be calculated by this. 6 is given to star P. Means what? Wherever P is pointing, that memory location you are changing. That memory where P is pointing now to this. So indirectly what you are changing, this location you are changing in this fact. So here prod is given to star P means product will be given return here. There is no explicit returning here. Implicitly through pointer you are accessing variable of main. So when you send by reference, you will have whatever change. This is by reference you are sending. By reference means whatever change you will make in this P, because this address you are passing, P you are changing here. In this P, that is reflected back in caller also. This function is accessing result. That function is accessing this memory indirectly through pointer variable. So this is by reference also, without returning explicitly. Implicitly you can return that. This I have shown as an example how we can write a function by sending call by reference, right? So this is the way we should think for writing functions. In future videos, I'll take many examples like this, how we should think of writing these functions. Many things you should know in functions actually. We have seen simple example here, and you should know how to send arrays to a function, how to send structures to a function. So these things when you'll know, then definitely you can write any program very easy. So during course whatever we are taking, I'll cover all the cases. We will write only functions. I never write one main only. Or whatever concepts, whatever programs we will see in future, that definitely will be only with functions. And how to think, whatever thinking you are doing, how to convert that thinking into a program, that we will see. Thank you.